So in the first video, 3.1, we discussed what a polynomial function is. We've tried to classify it. So remember, a polynomial function, you've been dealing with polynomials for many years. A polynomial function is a function in which variables have integral exponents, and only integral exponents. And one thing I don't believe I did all that great are these two bullets right here. If the function is an even degree, now even degree, I think of a quadratic, I'm the master of the quadratic. If the function has an odd degree, and we're just going to talk about the left hand and right hand side behavior. So I've sort of recreated these graphs again, and I'm going to go here, odd degree functions. If the leading coefficient we're talking only odd degrees. So if the leading coefficient, the graph is increasing from the left and increasing as it exits to the right. So I'm just going to make a quick graph here. What am I talking about? If my graph is y is equal to 2x plus 1, my leading coefficient is positive. What we notice is that on the left-hand side, my graph is increasing, and on the right hand side my graph is increasing. Now I'm going to give you another odd degree function in which the leading coefficient is positive. Well, what does the left hand right hand side shape looks like? Well, it might look like this. So overall, I can say all odd degree functions with a leading coefficient that is positive will have this overall. On the left hand side, the function will be increasing. On the right hand side, the function is increasing. Now if my leading coefficient is negative, such as y is equal to negative x plus 1, or y is equal to negative 4x to the power of 7 minus x, well, here we take a look, my leading coefficients are both negative and the degrees are odd. Well, what will that mean for my picture? Well, I don't really know. Well, I do know for the linear function that my graph is going to be pointing downhill. But as we say, it is decreasing from the left and decreases as it exits from the right. Now, this function, I may not know how to graph it, but all I need to know is that the leading coefficient is negative and the exponent is odd. And I'm just going to put a green box here. I don't know what happens in the middle of the graph, and that's really an argument for, I believe, 3.3, 3.4. But what's going to happen is if this is an odd degree function and my leading coefficient is negative, it's going to look something like this. Now, what's really important here is that on the left-hand side, my function is going to be decreasing as it exits on the right-hand side. Now, what happens here? How many turns? Well, that's a total different conversation for another lesson. Now, even degree functions. Even degree functions, well, you're the master of quadratics. When my leading coefficient is positive for an even degree function, well, you know what this is. It would be a quadratic. So this is what we have. My graph is decreasing from the left and increasing as it exits to the right. That is, you guys would say it points upwards. I'm going to make another function, a quartic function here. Now I could put as many terms as I want. It doesn't really matter. But as long as my leading coefficient, I'll make my leading coefficient positive 5. Pardon me, that was almost a really bad mistake. What's going to happen is that my function could take many different turns. And again, what happens in the middle, I actually don't really know. But for my left-hand side is that my function is going to be decreasing. On my right-hand side, my function's increasing. Now, if my leading coefficient is negative, such as y is equal to negative 2x plus 1, or y is equal to negative 8, x to the power of 4, plus a whole bunch of things, well, what we know is that my graph will be downwards opening. That could represent the quadratic. Or the quartic function, too. It could look like a lot of craziness. But what can we say about this just looking at the degree and the leading coefficient? This gives me my left-hand and right-hand side behavior that if my degree is negative, if my degree is even, my leading coefficient is negative, my function will be increasing as it enters from the left and decreasing as it enters or exits from the right. No matter what the other variables are, that's the way it is. Or in common terms, you would say it opens downwards, exactly like parabolas. So all odd degree functions behave like linear functions when considering their leading coefficient, and all even degree functions behave like quadratics on the left-hand and right-hand side when you take in